Hi guys. Today I'm coming to you live from in the middle of the Pacific Ocean because today in our lecture and in our lab we're going to learn about the amazing properties of water, and we're also going to learn about the properties of acids and bases. All right, so now our daily objectives. So these are things that you should be able to do at the end of class today. If you can't do these at the end of class today, congratulations, you just wasted 90 minutes of your life. So, number one, you should be able to describe what hydrogen bonds are and what polar molecules are. Number two, you should be able to identify the characteristics of both acids and bases. All right, I hope you enjoy it. Hello, everybody. Welcome back to another edition of Edpuzzle Lecture Notes. Now, remember, with these notes, we need to get 75% or higher for it to count. If you get 75% or higher, I'm going to give you 100%. So that's good. But if you get 74% or lower, that equals 0%. So you need to get 75% or higher in order to get credit for this assignment. Now, how can you do that? Here's one idea. Actually watch it. Don't just let it play in the background. And number two, to make sure you get the questions correct, how about taking down some notes so when the questions pop up, you'll have the answers right there. All right, so properties of water. So those of you guys that did the molecular models, you saw that water has a bent shape. It's not a straight line, so it kind of looks like this. And that becomes important because water is what they call polar. Polar. And all that means is that water on the oxygen side has a negative charge, and on the side with the two hydrogens, that side has a positive charge. So that's what makes it polar, because it's got two different poles, kind of like a north and south pole. It's got a negative side, negatively charged side, and it's got a positively charged side. Now, why that occurs, it's going to be down here. Electrons, those negatively charged electrons, are more strongly attracted to the oxygen. So they want to hang around the oxygen a lot more. So therefore, since oxygen has a lot of those negatively charged electrons flying around it, that side gets a negative charge. And the other side with the hydrogens gets a positive charge. So that's all a polar molecule is. It's molecules which have slightly negative sides and slightly positive sides. That's what makes them polar. And now going into hydrogen bonding, it goes with the last slide of water being a polar molecule. So if you look down here, these are little water molecules. There's, 5 of them there. And you can see that it has a negative side and a positive side. Well, what you need to remember is that opposites attract. So the positive is attracted to the negative, and the negative is attracted to positive. Positive and positive, those repel, so those do not attract. So it's negative and positive, those guys are attracted to each other. And you can see that here. So water molecules tend to sort of stick together. And they do that with hydrogen bonds because the positive side of the water is attracted to the negative side of another water molecule. Same thing with this one. The positive side of this water molecule is attracted to the negative side of that water molecule. So they tend to all weakly bond together. And that's what's called a hydrogen bond. Not a hydrogen bomb, but a hydrogen bond. That is a very weak bond that occurs when you have hydrogen atoms bonded to what's called very strong electronegative atoms like nitrogen, oxygen, or fluorine. Well, in this case, it's oxygen. So oxygen side of the water is going to have a negative charge, like right here, because remember, a lot of those electrons are attracted to the oxygen. So this side of the water gets a negative charge, where the other side with the hydrogen gets a positive charge. And then the opposites attract. So the negative side of one water molecule will be attracted to the positive side of another. And the hydrogen bonds, since water is polar, it gets water, it's kind of like cool features. Like here you can see a drop of water that went into a pool of water, but you can see all this water clumps together. It doesn't just fly all over the place because the water is bonded to each other. For each water molecule, remember, you got a negative side and you got a positive side. Well, the negative side of one water molecule is going to be attracted to the positive side of another. So they kind of stick together. Opposites attract. So the negative and the positive, they bond together in a weak hydrogen bond. That's also what allows this little insect right here to walk on water. Because the water underneath his little feet, they're stuck together. Those water molecules are bonded together through weak hydrogen bonds. Now obviously, the bonds are not strong enough to allow things like us to walk on water because we're far too heavy, but they do stick together enough to allow this little insect to walk on water. And you can see here, these drops of water, which are hanging down from these pine needles, you can see how the water is actually, they're stuck together. If they weren't, they would fall off of that pine needle. Well, the water is also stuck to the pine needle because that is made of mostly cellulose, and that is also polar, so they kind of stick like little magnets. All right, so here's the two terms. Cohesion. Cohesion is an attraction between molecules of the same substance. So, water sticking to other water molecules through hydrogen bonds, that's cohesion. Water sticking to water is cohesion. Now, when water sticks to things like paper or to things like pine needles, since those are different substances, that's called adhesion. So that's an attractive force between molecules of different substances. So cohesion, same substances. Adhesion, an attraction between molecules of different substances. And real quick on this one, once again, water is polar because water has a negative side, the oxygen side, and it's got a side of it that's positively charged. That's the hydrogen side. And opposites attract. So the positive side here will be attracted to the negative side, so they form a weak hydrogen bond. The attraction between the positive and negative sides, that's what allows water to stick together in weak hydrogen bonds. And now one more slide after this one. Acids. Just the straight definition. I know you guys have heard of acids. You know they burn you. But what really is an acid? An acid is any compound which produces or releases H plus or hydrogen ions in solution. So these are things, if you put them in water, they create or release a lot of these H plus hydrogen ions. So that's one thing you need to know about an acid. That's the type of ions they produce, H plus. The other thing you need to know is their pH value. They have a pH between 0 and 6.99 pH. If it is exactly 7, 7 is pure water. So anything below 7 is considered an acid. Now, on the other end of the spectrum, another very dangerous thing that can also burn you, those are called bases. And you need to know two things about a base. Bases produce OH minus or hydroxide ions when they're put in solution. So if you put something in water, if it produces OH minus or hydroxide ions, it is considered a base, and it has the opposite pH. So if 7 is pure water, it is higher than 7. So it has a pH between 7.01 and 14. So that would make it a base. Now, for bases, the closer you get to 14, the more powerful the base. So like 7.01, most water is not even exactly 7. So that would be totally harmless. Where 14 would basically burn your face off. Same thing with acids. 6.99 is real close to 7. So 6.99 wouldn't do anything. The coffee I drink in the morning is more acidic than 6.99. But once again, once you get close to 0, that'll once again burn your face off. So the closer you get to 14, dangerous. And the closer you get to 0, dangerous. We're in the middle, around 7, pure water, harmless. All right, so pH scale, that's just a scale that measures the concentration of H plus ions, and it tells you how basic a substance is or how acidic a substance is. And remember, it goes from 0 to 14, with 7 being neutral, pure water. And the last slide here, this is terrible little graphic over here. It didn't come out good. But you can see some different things in how acidic or how basic they are. So this is stomach acid. You can barely see it right there, and that's like a 1. That's hydrochloric acid. Very, very acidic, very dangerous stuff. Tomato juice is a 4. You know, that's pretty acidic, but obviously it doesn't hurt you. Acid rain is like a 5. Soap, that's basic, and it's a 10, but, you know, soap is not going to hurt you. But as you go up higher on the pH scale, it's going to get more and more basic. These become more and more dangerous. Like ammonia, that's a cleaner. That's around a 11, 10, 11.5. And when you get up here with like oven cleaner, getting up to 14, that's very dangerous. And remember, pure water is neutral, and that is 7 on the pH scale. All right, thank you very much for watching. Hope you enjoyed it, and I'll talk to you next time.